represent the rate of, right? And we have discussed what is the direction and all of that gradient. So now the question may be asked that first of all that if so is there any situation where the gradient is 0, right? So what kind of situation or what kind of potential or what kind of scalar field is having gradient 0, or what is the actual meaning of gradient 0 or gradient is equal to 0? Any example, anyone would like to give some example of scalar field of gradient 0? Anyone? Anyone can
Sir,
switch on
suppose
the
is
speaker and yes, please.
sir, suppose a surface where we have a, I mean, very constant scalar distribution, means suppose the field, the scalar field doesn't depend upon any variable like x and y, and just simply it's suppose an electric potential is given, not a function of any coordinate, not a function of any coordinate. Suppose simply 60 volt or like that. So in that case, I think the gradient will be 0 because everything is constant and the partial derivatives will be 0.
Okay, so you mean can you give some real example? Like you said that there is a potential 60 volt, and then the gradient will be 0. But where you are applying the potential and where is you are calculating the gradient? Can you elaborate a little bit, or with some physical object or physical example which I can visualize or everybody can visualize? Can you explain a bit in that
Sir,
direction?
equipotential surface.
Equipotential surface, yes, equipotential surface is gradient is 0, but I mean any real example, like for example that's what Chiranjeevi, yes, Chiranjeevi says that if there is a potential and then the corresponding to this potential there is some surface where the potential is not changing, their gradient is 0, right? Chiranjeevi, you mean that?
Yes, sir. Yes.
Yes. So, for example, you have a charge particle at the center of a, means somewhere you kept the charge particle and you draw a sphere around it, right?
Yeah.
So on the
Yes, sir.
surface of that sphere, your gradient will be, means the gradient of that. So is that, do you mean that?
Something like that.
Mm-hmm.
I
So,
mean,
other people or Alok, do you agree on that? That okay, if I put a charge on,
Yes, sir.
mm-hmm. What about others?
Yes, sir.
So yeah, Chiranjeevi, you can switch off your. Yeah, thank you. So okay, so surface or sphere, and where at the center of the sphere there is a charge particle. So the according to Chiranjeevi, that charge according to Chiranjeevi, the gradient of the scalar field at point on the surface is 0. Okay, so another example I can think of is like due to the gravitational field or gravitational potential, or if I think about gravitational potential, like you are moving on a, let's say a particle is moving on a surface in your home, so that the potential or the yes, the gradient of the potential that particle will feel is also 0 because you are on a same plane. The particle is moving on the same plane, so there also the potential is or the gradient of the potential from one point to another point is 0. So these are the examples, but if you are moving away from that point, then what will happen to the gradient? Or if you are calculating the gradient along the normal to the sphere. Okay, now, so I gave one example. Yes, in the last class, if you remember, it was on page 6. I don't know whether you people have followed that or have gone through after the class. I'm not sure whether you have gone through those sheets after the class. But what I want to, yes, Ipsita, yes, please.
Sorry, sir, there is Sweta Chahal says unable to listen your audio. Can you please record this session and share it later?
Yes. So, yes, because I forgot today to record. Yes. So, is there any problem for her? So, Sweta Chahal, Ipsita ji?
I don't know. Sir, she shared that I'm trying to connect, but I'm unable to. That's why I'm requesting you to record the session.
Okay. Okay, no problem. Yes. Yes. Okay, so what I was telling is that last class we discussed an example, or I asked you, we discussed if there is a surface and then what is the directional derivative of that surface at some point and along the tangent of a curve, right? So the curve equation was given. So my question is, did anybody try to understand how this tangent has been calculated, or how do you get that tangent?
Yes, sir. I mean, you have provided a vector, and we simply did the differentiation of that vector to find the equation of tangent.
So how physically that means the tangent? Do you get, or do you try to
Sir,
understand?
it is because the slope of a curve is given by its derivative, and
Yes.
something related.
It is xyz, then you just take